Welcome to the Stat 201 Beyond the Lecture video series. This is Lesson 1.1, which is an introduction to statistics. Hopefully by the end of this video, you will be able to read a problem and identify the subjects, the sample, and the population, as well as to describe a summary value as either a statistic or a parameter. The question is, why does this matter? Well, it's all about providing us with context. So we want to know who we are collecting data about, what the data that we are collecting is, and when this occurs, because all of this information helps us better understand and interpret our information, our data that we collect. So I'm just going to briefly kind of review these three definitions for us. So a subject is what we study. They are usually people, but not always people. They could be places or things. It's whatever you want to try to collect data about, and they are the individual level values. From there, we're going to look at a sample, which is a group of those subjects that we collect the data about. And in this case, whenever we try to describe a sample, we refer to that as descriptive statistics. So descriptive statistics is looking at the sample data and trying to summarize it in some way, shape, or form. Those summaries that we would calculate or look at in picture form are called statistics. And so we would refer to it as a sample statistic. Notice again, that first letter is going to be really important. So a sample statistic, those two things go together. Whenever we look at sample data and try to make predictions about the population, we refer to that as inferential statistics. We are making inferences about what we think the true population is. Now, the population is all possible subjects. Now, there are plenty of situations where there's not enough time or not enough money to go visit every single person, place, or thing that we care about. And so in that situation is where we come up with the idea of a sample as the people, places, things that we actually go and collect the data on. But we still want to recognize that the population is generally much larger than the actual sample. Whenever we summarize that population, we will call that a parameter. Now notice again, those letters match up, so we have a population parameter. Both of those start with a P, sample statistic, both of those start with an S. So you know which ones match up. We know which ones go together. Now, I'm going to go ahead and jump into an example. Here is a great moment to pause and go ahead and try the problem on your own. So the question says, the Wellness and Fitness Center at the University of South Carolina surveys 100 students about the number of Group X classes they attend per month. From these survey results, they find the average is 5.2 classes per month. I put in bold these couple of things that we want to pay attention to. Number one, that they surveyed 100 students and that they found an average of 5.2 classes per month. Those things are going to come in handy a little bit later as I do the problem. What I want to do is I want to match each description of a subject, a sample, and a population to these definitions down here. So part A says that all. Now I want to point out, this is all University of South Carolina students. Based off of that keyword, I'm going to say that A is a population, because again, when I look at every single individual that I could, in this case the students, that's going to be our population. I may not collect data on all of them, but it's every possible one that I could look at. For B, it's the 100 students that actually responded to the survey. So it's the students that I collected data on. And again, that's from our problem up here. So in this case, that is our sample, the 100 students that they actually collected data on. And the last one we have each. So this is actually talking about the individuals. And so in this case, each individual University of South Carolina student is going to be our subject. Again, we only collected data on 100 of them, which is our sample. Again, here's the rest of that question. So if you want to pause here and try the question on your own, now's a good time to do it. So in this one, we're talking about the average of 5.2 classes per month is either a statistic or a parameter. Again, that's important information given to us in that problem. Since this is just based off of the data that they collected, it's just based off of the survey results that they had, it is going to be our statistic because it's just based on the 100 students in the sample. From here, I'm going to try and do one more example, and then we'll recap at the end. So one more example. Again, pause here if you want to try the problem on your own. So last month, the McCutcheon House dining room had a total of 480 dinner reservations. So they had a total of 480 dinner reservations and an average party size of 3.6 people. To evaluate service patterns, a manager randomly selects 40 dinner reservations from the last month and finds that for these reservations, the average party size is 3.4 people. So we have two bits of conflicting information. We have every dinner reservation in the last month and then a select few of those dinner reservations from that last month. Well, again, if I want to talk about subjects, I'm going to talk about the individuals. Now, notice in this case, we're not talking necessarily about looking at individual people. We're actually looking at each individual dinner reservation from last month. For the sample, we're going to look at the 40 dinner reservations that manager selected. And finally, for the population, it's going to be all 480 dinner reservations that they had last month. So notice I'm trying to build this up so that you recognize that the subjects are each, the sample is whoever we're collecting the data about, and the population is all. So one more time, we're going to have one more follow-up part to this. So again, we're just looking at matching these things up. Take a moment and pause the video if you want to try this on your own. So we want to match each number to the correct term. We have a statistic and a parameter, and we just want to know which one is which. Well, so in this case, they looked at all 480 dinner reservations and found the average party size of 3.6. So this goes with all 480 reservations. And the 40 dinner reservations goes with the 3.4. So this is only the 40 reservations. So in this case, the statistic is A, the 3.4, because that's going to match up with our sample. And the 3.6 is going to be our parameter because it goes with our population, which is all of those dinner reservations. Now, that being said, let's go ahead and quickly recap. So subjects are our individuals. They're going to be some kind of singular noun. We usually use the keyword each for this. For our sample, it's a group of those subjects. For the population, it's all. It's the collection of every single subject. So I'm going to write the word all for our keyword there. Statistics and parameters are like adjectives. They're just designed to describe the information that we collected. Again, for statistics, it's a sample statistic, and for parameters, it's a population parameter. And just be careful of the pitfall. Subjects aren't always people. They can sometimes be places or things as well, like for our example, our dinner reservations. I hope this helps, and I'll see you in the next one.